Show each step and simplify each expression. Okay, so in this first problem, we don't see an equal sign, so it's just an expression. So we're not solving for x, we're just going to simplify or make it a smaller problem. So to simplify this expression, we're going to, first we would distribute if possible. So here I will distribute the 4 to each of those terms, and then we will combine like terms. So 4 times 5 is 20 x's. 4 times negative 7 is negative 28. And then minus 3x minus 6. Okay? And we will combine like terms. So we will add the x's together, and we will add the whole numbers together. Okay, so we have 20 x's here and negative 3x's here. So together, that gives me 17 x's. Okay. And the negative 28 plus another negative 6 gives me negative 34. So we're combining these. So minus 34. And this term here has an x, and this one does not. So we cannot combine them together, so that is the simplified expression. Okay, number 2. Same thing, we would distribute if possible. And in this problem, I see we're going to distribute 5 to each of those. And then we're going to take this negative 3 and distribute it to each of those. 5 times 2x means I have 10 x's. 5 times negative 9 is negative 45. And then we're going to take this negative 3 and multiply it times each of these. So negative 3 times x is negative 3x, so minus 3x. And negative 3 times 4 is negative 12. We will now combine the x's. I have 10 here and negative 3 here. So together I have 7 x's. And negative 45 plus another negative 12 gives me negative 57. Okay, number 3. Find the y-intercept, the x-intercept, y-intercepts, and slope in the following linear equations. Okay, so the first thing I want to do is I can see that this will be an easy problem to solve for x and y-intercept. So I will solve for the x-intercept first. Let's write this. We're going to write our answers in ordered pair. All right, so we need an x and y value. And if I'm looking for the x-intercept, I'm looking for what is, I'm going to solve for x. What is the value of x when y is 0? So I'm going to put a 0 here for y. And then I'm just going to act like, or well, we would multiply 4 times 0 is 0. So we're just going to act like that 4y is not there at all. So I'm going to rewrite the problem as 3x equals negative 24. Right? Because y was 0. There's none there. There is no y. So now I will divide by 3 so I can solve for x. And I end up with 1x equals negative 8. Okay? So that's how I find the x-intercept. To find the y-intercept, I am going to make the value of x 0, and we're going to solve for y. So I'm going to just act like this 3x isn't here because 3 times 0 is 0. Right? So we'll just act like it's not there. And I rewrite this as 4y equals negative 24. I will divide by 4 and get 1y equals negative 6. So the y-intercept is negative 6. Now all we have left is to find the slope. So we will take this standard form equation and we will put it into slope-intercept form. So y equals mx plus b. For space, so I'll have space to work, I'm going to rewrite the equation over here. So 3x plus 4y equals negative 24. And I'm going to isolate the variable y. So I want to get y all by itself. So to do that, I will get rid of this 3x. I will move it to the other side. And we have 4y equals negative 3x minus 24. And our last step would be to divide by 4 so that we can get 1y. So 1y equals negative 3/4 x minus 6. Okay, and right here, right, that's the m in mx plus b. So y equals mx and then plus b. So m is slope, so our slope is negative 3/4. Okay, number 4. We're going to look for the x and y intercept and the slope again. So first we will start with the x-intercept. So we're going to say that the y is 0 in this problem. And we are going to solve for x. So up here, if I put 0 in for y, negative 4 times 0 is 0. So we can just act like that's not there at all. And we solve for x. So when y is 0, x equals 8. Okay. And to find the y-intercept, we're going to substitute 0 in for x and solve for y. Okay, so 5 times 0 is 0, so I'm left with negative 4y equals 40. I'm going to write that down and solve for y. So divide by negative 4. We find y is equal to negative 10. Okay. Now to find the slope, we will take this equation, we're going to rewrite it over here, and then we're going to put it into slope-intercept form by moving the x's. And dividing by the coefficient or the number in front of the y. Okay, so negative 4, that's 1y equals 5/4 x, right? I had a negative 5 divided by a negative 4. That gives me a positive. And then 40 divided by negative 4 is negative 10 or minus 10. So I will take the slope, which is the 5/4, and we will write it down over here, 5/4. All right, number 5. Given the function b of x equals negative 4x plus 9, find the following. Okay, b of 6. So what this is wanting us to do is take this 6 and substitute it in for x into this equation, and then find the value of this whole thing. So find the value of y, basically. All right, so b of 6 equals negative 4 times 6, right? I'm substituting that in for x, plus 9. And I'm not going to write b of 6. It's just the same thing all the way down. That's not changing. That's just a way to name it. Right? Same thing as y equals. Okay, so negative 4 times 6 is negative 24, plus 9. Negative 24 plus 9 is negative 15. So b of 6 equals negative 15. Now if I wanted to use my calculator instead, I would have just taken this and I would have typed it into y equals, because b of x is the same thing as y. So you push the y equals button, type that in, and then we go look in the table in the calculator to see if when x is 6 what the output or what y will be. Okay, number 6, we do the exact same thing. So this time we're going to substitute negative 4 in for x instead of 6. So negative 4 times negative 4 plus 9. Negative 4 times negative 4 is negative 16. Negative 16 plus 9 is 7. So the value is going to be 7. Okay, number 7, b of 0. So they're asking us to substitute 0 in for x. So I'm going to go ahead and write b of 0 equals negative 4 times 0 plus 9. Anything times 0 is 0, and 0 plus 9 is 9. So when x is 0, the y value is 9. So if that was an ordered pair, it'd be 0, 9, which is also the y-intercept. Number 8, they're asking us to find x, right? This isn't Where's Waldo, so I'm not just going to point and say, well, that must be the answer for x, negative 59. No. We have to solve for x when b of x equals negative 59. So that's saying when y is equal to negative 59, what is the x value? So this problem is working backwards. So we're going to take the original problem, which was b of x equals negative 4x plus 9, and we're going to substitute negative 59 in for b of x, because it says b of x is negative 59. So that means this is negative 59. So negative 59 equals negative 4x plus 9. And now we need to find x, or solve for x. So we will move the negative 9, and that gives me negative 68 equals negative 4x. Okay, I'm going to divide by negative 4 on both sides. Okay, and I'm going to get 1x equals negative 68 divided by negative 4 is negative 17. Nope, positive 17. Two negatives divided is positive. So it's going to be positive 17. Okay, I'm going to slide that over a little bit. Put 17. So the ordered pair for this would be the x is 17 when the y was negative 59. And if I was to do this on the calculator, we would have typed in, to y equals, we would have typed in the negative 4x plus 9. And then we would have gone down on the y column until we found negative 59. And then we would have found that the corresponding x value was 17. So it would have looked like this in the table. Right? This would have been the x, this would have been the y, and they would have matched up. Okay, number 9. Identify the domain and range of each function. Okay, looking at this, it's not a single point. There is a point, but it's not a single point, so I can't just list that point or just list the x and the y. I see that it does start here, but it does not stop as I move this direction. Right? That arrow tells me it goes on forever. Okay, if it's going on forever from this point, I need to find out what direction is it going on forever. So there are two directions. You know, we can move left and right, or we can move up and down. Well, from here, it's moving down and to the right. So as I move to the right, it goes down. So those are the two directions. For domain, we're looking at where's the x, range, where's the y. So here, I can see that the x value, it starts when x is 2. And then from there, all of the values are getting greater because from this point we're moving to the right. Okay, so the values of x are greater than or equal to 2. For the range, we're looking at the movement for the y. So where does it start? So how high is it? We've gone up 5 units. So the highest point is 5. And from there, the arrow is pointing down, or the line's going down, so all of the values are becoming less. So we're going to write that as y is less than or equal to 5. Because as I move down the line, we can see that the values of y are getting less. So if I pick this point, the value of y is only 2. It's not 5 anymore. Okay, number 10. There is no graph so on this one, so it didn't show up for some reason. I'm going to skip that one. Number 11, given the equation y equals 2x minus 5, circle the changes that occur if the slope is doubled and the y-intercepts remain the same. Okay, I'm going to write the two equations down. So y equals 2x minus 5. That's line 1. And in order to have changes, we have to have a second line. And the second line will be y equals, and then we have to figure out what has changed. It says that the slope doubled. So 2 is our slope on the original line. So if we double it, it's now 4x, because 2 times 2 is 4. And the y-intercept remains the same, so minus 5. All right, I'm going to graph the first line. I'm going to graph it in blue. So we have negative 5 as our y-intercept. And then from there, we're going to go up 2 and over 1. And we'll continue that pattern. Okay. I'm going to draw my line. And for the second one, so that's line 1. Line 1. And for line 2, I'm going to go ahead and do that in red so I can see the difference. It also has negative 5 as its y-intercept. And that one's going to go up 4 and over 1. And we would continue that pattern. And we can see that there's the new line. That's line 2. All right, so letter A says the lines are parallel. Well, obviously we can see that the lines cross, and they actually cross at the y-intercept, so that's false. And the way to really tell is you look at the slope of each line. This one has a slope of 2, this one has a slope of 4. They're not the same, so they're not parallel. Lines are perpendicular. Well, to be perpendicular, they have to be two lines that cross. These cross, but they have to cross at a 90-degree angle. And these don't look like they cross at a 90-degree angle, but of course we would want to find out mathematically if that's true or not. So to be perpendicular, the slopes have to be opposite reciprocals. And all that means is if I take the slope of the first problem, which is 2, and I make it a fraction, the second equation here, the slope needs to be the opposite reciprocal. So it would need to be flipped. So we flip the fraction, and then we would change it from a positive to a negative. And obviously 4 is not the same thing as negative 1/2. So it's not perpendicular, so B is false. Okay, for C, it says the new line is steeper. That would be line 2. So if we look at these two lines, line 1 and then line 2, it's going up more. So instead of going up 2 and over 1, it's going up 4 and over 1. So it's going up more quickly, so it's steeper. So C is true. The new line is less steep. Well, obviously we just said it's more steep or steeper, so that's going to be false for D. The x-intercepts are the same. Well, when I look at the graph, I see an x-intercept here, and I see one over here. So they are not the same. So that's false. And the y-intercepts are the same. Well, they both have negative 5 for the y-intercept, and we see that on the graph. So that is also true. And it says circle the ones that are true. So answer choice C and answer choice F. Those are both true. And number 12. On problems 12 through 13, solve and graph the inequalities. Okay, so number 12. We need to solve, and in this problem, we need to solve for x. All right. So one single variable. So our answer is only going to have one variable. We will use a number line to represent that. So 3 times x is 3x. 3 times negative 9, negative 27. We're saying that needs to be greater than or equal to negative 6. I will add 27 to both sides of the inequality. and I get 3x is greater than or equal to 21. Divide both sides by positive 3. Remember, if I divide by a positive, we don't do anything to the inequality symbol. We just leave it the way it is. So it was greater than, it stays greater than. I'm just going to throw a 0 here, 7's here, and we're saying the values of x are greater than 7 or equal to 7, so it's going to be a closed circle since it's equal, and greater, we would move that direction. On your graphs, they're going to fill in a few more numbers, like on the tests, and you just have to pick the one that it is, and then pick the correct direction. Okay, 13, I'll do that one in blue. We're going to solve for x. So I can see that I have an x on both sides. I want it only on one side. I'm going to go ahead and move mine to the left. So we're going to move it from this side by doing the opposite. So negative x is less than 34. I'm going to add 11 to both sides. And I end up with 4x is less than 45. And I'm going to divide by 4. And we get x is less than 11 1/4, or 11.25. Okay, so if I'm graphing that on this line, I'll do that in black. So if I said this was 0, and this is 11, and this is 12, right? 11.25 is going to be about right here. And the values of x, we're saying, are less than that. So we will move to the left to show less than. Okay. All right, number 14, write the inequality for the given graph. All we're doing is we're saying that all of the values of x, or whatever letter we're picking, are between these two numbers. Right, so everything in between we need to count. Right here, I see an open circle, and right here is a closed circle, so not equal to, equal to. And this is a compound inequality. We'll write it like this. So negative 6 is the least value, and we're going to use an open circle because it's not equal to whatever number we pick for x, so anything in between here. And then that number, x, whatever number it is, has to be less than or equal to 1. Okay, so less than or equal to 1. We're saying 1 is the highest number it can be, and negative 6 is the lowest it can be. So everything that I pick has to be between these two numbers. Number 15, given the equation 2x minus 3y equals negative 12, write the x-intercept and y-intercept as ordered pairs. Okay, so going back to intercepts, when I see the word intercept, I automatically think of something has to be 0. So to find the x-intercept, we're going to make the y 0, and we're going to solve for x. We're looking for the x-intercept. So where does it go on the x-axis? To do that, we're going to make y 0. Negative 3 times 0 is 0. So we'll just cover it up or act like that's not there and rewrite the problem as 2x equals negative 12. Divide by 2. So when y was 0, the value of x is negative 6. So the ordered pair is negative 6, 0. Now to do the y-intercept, we're going to substitute 0 in for x. So right here, 2 times 0 is 0, and that leaves us with negative 3y equals negative 12. Divide by negative 3. Y is equal to 4. Okay. Number 16. What are the values of x so that the perimeter of the triangle is greater than 92? write your answers in inequality. All right, so perimeter, that's telling me right here that I need to add up all the sides. So I'm going to go look at my triangle. I want to add up all those sides. Of course, we can only combine like terms. So I'm going to take the x's and add them. I have 2 here and 3 here. Gives me 5x. And we will add the whole numbers. So 17 and 3 is 20. And then 20 plus a negative 8 is 12. So plus 12. And we're saying that that perimeter here has to be greater than 92. So that perimeter is greater than 92. Doesn't say to solve it. It just says, oh, well, it says what are the values of x? Yeah, so we do need to solve it. And then we're going to write our answers in inequality. We will split the sides. We will take 12 away from both sides. So I end up with 5x is greater than 80. And we will divide by 5. And x is greater than 16. So that means in order for this perimeter to be greater than 92, that value of x, each one of those, has to be greater than the number 16. Okay, and we could take any number and plug it in for x, or substitute it in for x, and then solve it and see if, or evaluate it and see if it's greater than 92. Okay, for 17 through 19, we're going to write the inequality for the graph, for the given graph. The way that I do these is, first, we know that if we're going to write an inequality, it's going to be y is greater than, y is less than, or greater than or equal to, less than or equal to. So my first step is I'm going to go ahead and write y. And if it's an inequality, we need to determine, is it greater or is it less? So I look at how it's shaded. So if this is my line, and I'm looking at the shaded area, are the values of y, are they greater than that line or are they less than the line? Well, obviously we're moving up into the shaded area, so those numbers are becoming greater. So y is greater than. And then we have to look to see if it's equal or not. I see a solid line, so I know that it is equal to. So the values of y are going to be greater than or equal to. And the only thing left is to find the slope and the y-intercept of the line itself. Okay, the y-intercept is here, which is at 4. So our b is 4. And then our slope is how much it moves. I see a point here and a point here. So I'm going up 2 units and over 1. Okay, so my slope is 2 over 1. And my y-intercept was at 4. And right here again, we see that we're going up 2 and over 1. All right, so the inequality is y is greater than or equal to 2x plus 4. Okay, number 18, we're going to do the same thing. Okay, so y, and we're going to find out, is it greater or less? So if we're talking about the shaded area, it's below the line, so that's less. So the values are less. And then, is it equal or not equal to? So I look at the line itself. It's a dotted line, so not equal to. So we're just going to leave it as y is less than. And we need to find the m and the b. Okay, the b is our y-intercept, so it's crossing the y-axis at -2. And the slope, we could use that point, and it looks like this might be another good point right here. It is a positive sloped line, right? So our fraction is going to be positive. So our slope's positive. So we're going to go up 3 and over 4. So 3/4. Okay, so we have 3/4 x minus 2. Okay, number 19. This is one of those special case problems. We can see that we have a zero-sloped line, and it only crosses the y-axis here. Okay. So we're only going to have one variable, which is y. And the value of y is -1. And we have to decide, are the values above or below the line? So it's below, so it's less than. And we have a solid line here, so it's equal to. And we said that the value was -1. So all of the values of y that I can pick, no matter where I'm at, right, I have to go, it has to either be on the line, which is -1, or below the line, so less than the line. Okay. Number 20. Which coordinates are not in the solution set for y is greater than 6 minus 5x? So for each of these, I would just substitute the x, y values in. So we will label xy, 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 and xy. And it says which coordinates are not in the solution set. So that just means which ones are not an answer, which ones does not, which one of these problems, or which one of these solutions does not keep this inequality true. Okay, so we're going to take these x, y's, and we're going to substitute them in for x and y. So y is greater than, so 0 is greater than 6 minus 5 times x, or 5 times 2 in this particular problem. So -5 times 2 is -10. 6 minus 10, or 6 plus -10, is -4. It says, is 0 greater than -4? Is that true or false? Well, that's true. Okay, so that means that is an answer. All right, so we will try 1, 1. Can't really mix those up, x and y, because they're each 1. So I'll rewrite it as 1 is greater than 6 minus 5 times 1. And -5 times 1 is -5. 6 minus 5 is 1. So is 1 greater than 1? And the answer to that obviously is no. They're the same thing, so they're equal. So that is a false statement. And we will do the next one, 0, 7. So y is 7. And we're saying that that is greater than 6 minus 5 times 0. So 6 minus 0, which is still 6. So 7 greater than 6. And the answer to that is yes. So that one is true. And we'll check the last one. Y is 12. We're saying that's greater than 6 minus 5 times -1. So 12 is greater than 6, and -5 times -1 is +5. 6 plus 5 is 11. 12 is greater than 11. Yes, that is true. So which one is not in the solution set? B. That would not be one of the solutions. Number 21. Which inequality has 3, 5 as a solution? Look, we're just going to take this xy value and we're going to substitute it into each one of these inequalities and see which ones are true or false. Okay, so I'm going to label xy so we don't get them mixed up. So x is 3. 3 minus 2 times the y, which is 5. We're saying that that number is greater than -4. So 3 minus 10 is greater than -4. -7 greater than -4. So true or false? Well, to tell if it's true or false, we have to kind of visualize it on a number line, or we have to really know about our numbers. Well, -7, even though 7 itself is larger than 4, when we're talking about negative numbers, if we're on a number line, -4 would be here and -7 would be here, so that number is less. So this is a false statement. -7 is not greater than -4. Okay, so this one's false. In letter B, we're going to substitute the same values in. So it's 3 minus 2 times 5, and we're saying that that's less than or equal to -4. Okay. It works out the same, so 3 minus 10 is less than or equal to -4. 3 minus 10 is -7, and we're saying is that less than or equal to -4. And I just explained that above. -7 is less than -4, so that makes B true. For letter C, substitute again. It's 3 minus 2 times 5, and we're saying that that's less than, what did I write there? 2 times 5. There we go, 2 times 5. And we're saying that that is less than -4. Okay, that didn't turn out very good. Alright, so 3 minus 2 times 5 is less than -4. So 3 minus 10 less than -4. And is -7 less than -4? And the answer to that is yes. So that's true. And for letter D, it's 2 times 3 minus 5 is greater than or equal to -4. So 6 minus 5 greater than or equal to -4. And 6 minus 5 is 1. And 1 is greater than or equal to -4. That is also true. So there's 3 true answers here. And the question says which one has 3, 5 as a solution. Well, that would be all of the true answers. I think this was probably meant to be written as which one is not a solution. But since that's what it asks, we're going to circle all 3 answers. On a test, it won't look that way. It's not written as a mistake like that. All right, number 22. Given the inequality graph below, find the following. All right, slope of the line, or the M. We just need to find 2 points that we can use. I see one here, and another good point here. Okay, so I can see that the line itself is moving in a downward direction, so that's a negative slope. And now we need to do how much is it going down. So we can look at the distance between here. So it's going down 1, 2, 3, 4, 5. And the distance from here to here is 2, so it's -5 over 2. There's your slope. The y-intercept, it is up 3 units. So we can see that here, 1, 2, 3. And which inequality symbol will we use? Well, the shaded area is below the line, so that means it's less. So we're going to either use this one with just the less than symbol, or less than or equal to. So now out of those two, we have to decide, is it equal or not equal? And I do that by looking at the type of line that we drew, and I see that it's dotted, so it's not equal to. So we're going to choose this one here, just less than. And they want to know, is -1/4 a solution? I could write the equation of the line. It didn't ask me to, but I could. And then I could substitute these values in and see if it remains true. Or I can take this point and I can see if it lands in the shaded area. The reason it can't land on the line itself is because it's not equal to anything on that line. That's why we have the dotted line. We're saying, hey, the only answers that are going to make are going to keep the inequality true are the things in the shaded area, but not on that line. Okay, so -1, 4. So -1 up 4. That's going to be right around here, right? And it looks like it is in the shaded area. So is it a solution? Yes. Is 3, -2 a solution? Well, we're going to go over 3. 1, 2, 3, and down 2. And it's in the unshaded area. So the answer to that would be no. Is 0, 2 a solution? So we're going to go 0 and up 2. And it looks like it's in the shaded area. So the answer to that is yes. For problems 23 through 25, graph the inequalities. So I'm going to graph each of these inequalities. First thing we want to do is we want to graph it, just the points that would be on the line, the individual whole number points that we can use. So we will start at -1, right? That's our y-intercept. So right there. I'm going to change colors. Let's right there. And our slope is 3/5. So that means go up 3 and over 5 from that first point. So we're going to go up 3 and over 5. Okay, so that's going to be right here. Up 3 more and over 5. And then we would continue the pattern backwards as well. Okay. Then, once we have our points, we have to decide what type of line are we going to use to connect the points. Are we going to use a solid line or a dashed line? And to determine that, we look to see if y is equal to or not equal to. And it's not equal to, so we're going to leave it as a dashed line or a dotted line, however you want to say it. So I kind of extend the dashes out a little bit past my graph so that I can make sure that it's dotted and not solid once I shade it in. So on your work, if if you're scribbling in the shaded area and you go across your line, like say you're working and you accidentally go across the line, and it looks like a solid line, the only way you'd be able to tell is if you extended it out just a little bit here so that you can tell and we can tell when we're grading your work. So make sure you try to do that to help yourself out. And now we have our line. So the values are not going to include the points on the line. Now are the values where I'm going to shade, are they greater than the line or less than the line? Well, right here is what tells me. It says the values are going to be greater. So I will shade everything that is above the line. So we're going to shade this area. Right? And it does include everything, outside of the graph forever, as long as it's above that line. Okay. Number 24. Same thing. We're going to graph 2x plus 3. We're going to act like it's y equals 2x plus 3, and we're going to put those individual points on the graph. And then we will work from that. So plus 3 is here. And the slope is 2 over 1. So I'm going to go ahead and put those points down. And then backwards. Okay. Then we have to decide what type of line are we going to use, and we see that it's equal, so we use a solid line. So I'm going to connect my dots with the solid line. You see that I extended it up past, so I can tell the difference. And our last step is we decide which way do we want to shade, up or down. Well, the values of y are less, so as I move on the y-axis to get less, we move down. So I will shade the lower region, or the region that's below the line. So there is my graph for the inequality. Okay, 25. This is not in slope-intercept form, so we have to put it into slope-intercept form in order to graph the line. So I will move the x to the other side. And I will divide by 3. Okay, so I end up with y is greater than or equal to, and I see a lot of mistakes right here. A lot of people forget that this is negative 1x, so they mess up with that 3 and they do something kind of funky there. So it's going to be negative 1/3 x. And then negative 6 divided by 3 is negative 2. So now I can graph it. So negative 2 is our starting point, and our slope is negative 1/3. So I'm going to go ahead and fill that in, move along, then work backwards. And it is a solid line because it's equal to. So I'm going to use a solid line, and we see that the values of y are greater, so we will shade the area above it, above the line. All right, so it's all of this. Okay, 26. Brandon is in the market to buy a snowmobile that will cost no more than $3,600. Okay, he worked the scoreboard at Minute Maid Park and received $900 and is currently saving $140 per month from his paper route. Write an inequality that could represent the time in M months to spend on his snowmobile. Okay, so he wants to buy a snowmobile that will cost no more than $3,600. And that's telling me right there that this is going to be an inequality. So he could spend less than that on a snowmobile, or he could spend exactly $3,600 on it. It just, that's the most he wants to pay, so no more than that. He made $900 working at Minute Maid Park, and he also saves $140 per month on his paper route. So we're going to write the inequality. So what I do is I give it some labels. I say how much he earns or has, or his money or whatever, and then what the cost of the snowmobile is. Okay. So the cost of the snowmobile at most is $3,600. Now, he earned $900 at Minute Maid Park plus $140 per month on his paper route. So when deciding how to put the inequality symbol, we know that the cost is going to be the greater amount because he doesn't want to spend more than that. So if he's going to earn money, he can earn either that amount, the $3,600, so it's either equal to $3,600, or if the snowmobile is less than that, he can earn less money than that. So that means he would work the number of months could be less than that, but he doesn't need to earn any more than the cost of the snowmobile. Okay, so it says write an inequality. It's not asking us to solve it, so that would be it for that problem. All right, if I was going to solve it, I would move the 900 over and divide by 140. All right, number 27. David plays in a string quartet and a jazz band. He gets $75 per hour in his string quartet and $80 per hour as the bass player in the jazz band. Write the inequality that describes his pay for playing the string quartet for Q hours and bass and the jazz band for J hours. Okay, so looking at this problem, we're not comparing anything to anything, so we can't set up an inequality. We can start one, right? It's $75 per hour for the quartet, plus $80 for the jazz band. But it's not, we're not setting a goal, or we're not looking at anything to compare it to. So this actually isn't a good question at all.